Okay, good morning, everyone. So we are proceeding ahead with the questions on capacitor. Now, specifically when dielectrics are involved, right? Let's look at this question now. The plates of a parallel plate capacitor are charged to 200 volts. A dielectric slab of thickness 4 millimeter is inserted between the plates. Then, in order to maintain the same potential difference between the plates of the capacitor, the distance between the plates is increased by 3.2 millimeter. Then, in such a case, what should be the dielectric constant of the slab? Okay. So let's look at the concept here. So let's say there is a parallel plate capacitor. Maybe we had connected it to battery and we had charged it to how much voltage? 200 volts. Okay, it's given in the question. Now, after charging this to 200 volts, we have disconnected the battery. Okay. Now, let's say the capacitance is C. The capacitance originally is C. We don't know what that value is. Let's say it is C. Let's say the distance between the plates of the capacitor is 4 millimeter. Now, what we are going to do is we are going to insert a dielectric slab of thickness 4 millimeter between the two plates. Okay. So what's the next thing that we are doing? Now this is already charged to 200 volts of potential. Now what will be the charge stored in the capacitor? Can you tell me? What is the relation between Q, C and V? Q is equal to CV.
Q is equal to CV.
Yes, therefore this will be, let's say the original capacitance is C. The voltage is 200. Therefore, Q will be equal to 200 C. Okay, this you can just make a note of it. Then, now what we are going to do is we are going to place a dielectric slab. Okay, we are going to place a dielectric slab here. This is step 2, right? You are going to insert a dielectric slab. Now, whenever we insert a dielectric slab, we have already seen that the capacitance will increase K times, correct? So the new capacitance will be equal to K times the original capacitance. So what will be the expression for original capacitance? If the original capacitance is epsilon naught A divided by D, where D is 4 millimeter, right? Now this will be equal to, the new capacitance will be epsilon naught K into A divided by D. You know that the capacitance will be multiplied by K times. It will be increased by K times, correct? Okay. Now here we are not connecting the battery, right? Earlier we had seen, what will happen if you keep the battery intact. Now we are not connecting the battery after the capacitor is charged. We are removing off the battery, which means what will remain still same is the charge. The charge will still remain the same, correct? Even though battery has been removed, capacitor will retain the charge. How much is the charge on the capacitor? That is equal to 200.
200.
Yes. So these are the points that we will make a note of. Okay. But usually when this happens, right, what will happen to the potential, let us see, correct? If the battery is connected intact, then potential will remain same. We saw it in the previous class. But now when the battery is not connected, the battery has been removed, only the charge is constant. Now what will happen is, according to the formula, if you see, the formula is Q is equal to capacitance into voltage. Now we are seeing here that after inserting the dielectric slab, capacitance has increased, correct? But charge has to remain same according to law of conservation of charges, because nobody is giving or taking away the charges. Suppose if you have the battery intact, then battery will be providing the charges or taking away the charges. But now battery is not connected. So charge has to remain constant, which invariably means that voltage has to come down, correct? Yes or no? Right? Suppose if Q was 10 into 1, let us say, or let's say 10 into 10, let us say 10 into 10, 100 Q, suppose, for example. 10 into 10, okay? Now capacitance has become 20, let us say, 20 units. Then what we must become? We must become 5. Then only 20 into 5 will become 100, correct? The product will be constant, right? So when capacitance increases, your voltage will decrease when charge is constant, right? So we will decrease normally. But what is given here? In order to maintain the same potential difference, right? Now, normally, if you don't do anything about this, potential will come down. But in order to maintain the same potential difference between the plates of the capacitor, what they're doing is distance between the plates of the capacitor is increased by 3.2 millimeter. So what we are doing is we are increasing this distance between the plates, right? So we have a dielectric occupying the space for how much distance? 4.2 millimeter. Then we are again further increasing the distance between the plates by 3 millimeters. So this distance is 3 millimeter, right? One second. Okay. Now, when you increase the distance by 3 millimeter, now what is going to happen is the voltage will again retain back to normal V. Okay. The charge is still the same. So in the new one, now in this arrangement, can you tell me how much is the Q? What is the charge? Charge will be the same charge. How much? 200 C. Yes. C, what is C? Epsilon naught A by D, correct? Now, how much is the voltage?
It's the same, sir.
It's the same. Voltage is the same, which is same as the earlier case, which is 100 volts. I'm sorry, 200 volts. Correct. Now, what is the capacitance? What is the capacitance given by? What is the capacitance of this setup?
E naught A divided by D.
Yeah, tell me, Alvin. Who was answering?
Sir, E naught A divided by D.
Yeah, epsilon V naught.
Epsilon naught A by D. So D will
Epsilon naught A by D. Correct?
And yes, sir.
Epsilon naught A by D, because Q and V are same. Q and V are same as the original one. So C also has to be same. Okay. But what is the capacitance of this setup according to our formula? Capacitance of the new setup. Let me call it as capacitance with the dielectric, D. According to the formula, we know that this is nothing but epsilon naught A divided by D minus T plus T divided by K. Do you remember this formula?
Yes, sir.
When both dielectric is also there and also air is there in between, right? So here in this formula, what are the quantities? What is D? D is in fact the total distance. Now, what is the total distance in this case? 7.2 millimeters. So D minus T will be actually 3 millimeters and T is 4.2, right? So now if you see, is equal to epsilon naught A divided by D minus T. D minus T is nothing but 3 millimeters plus T is nothing but 4.2 divided by K. And this capacitance is going to be same as this capacitance, the original capacitance, because charge is same and voltage is also same, which means the capacitance also must be same. Divided by D, that's all. So D is nothing but what? In that case, here I'll call it as D dash, okay? So what is the D? D is nothing but the original 4.2 millimeter itself. So you can see here also you have millimeters. So millimeter I can cancel. So millimeter gets cancelled, epsilon naught A gets cancelled. Now I can cross multiply. We get 3 plus 4.2 divided by K is equal to 4.2. So when I bring it to the side, 4.2 divided by K is equal to 1.2. So K is equal to 4.2 divided by 1.2 or 42 divided by 12. If I divide by 6, you get what? 7 divided by 2, which is 3.5. Let us see if we have such an option. We do not. Let's see what. D minus T is your 3 millimeters plus T is 4.2 divided by K. Epsilon naught A, okay. Let us see once more. Plates of a parallel plate capacitor are charged to 200 volts. Okay. A dielectric slab of thickness 4 millimeter. Not why? How did I make it 4.2? I'm sorry. It's given as 4, right? So this will be 7. Here also this is 4. Here also this is 4. Okay, let's see.
Sir, it's given as 3.2, no, sir?
3.2, ma? I'm sorry. 1 minute. Let me check 1 second. Yeah, 3.2, right? Okay, I made it 4 and okay, that's the problem. So this is 4 millimeter. This is how much?
3.2.
3.2 millimeter. Okay, so this must be
7.2.
Totally 7.2. That's correct. And here this is 7.2 minus T, which is 4. So I must write 3.2 here, right?
Yes, sir.
Yes, sir.
Yes. So 3.2 plus 4 by K is equal to not 4.2, 4. Okay, so 4 minus 0.8. What is it? Sorry, 4 minus 3.2. What is it? 0.8. So K is equal to 4.2 divided by 0.8, or in other words, 42 divided by 8. And what is 42 divided by? No, so not 42. This is 4.
40 divided. So 5, sir.
Yes, correct. I'm so very sorry. So 40 divided by 8, that's going to be 5. Therefore, the right answer for this question is 5. Clear?
Yes, sir.
Yes, sir.
Let me explain this once more. So we have a capacitor and the plates are separated by a distance of 4 millimeter. It is charged to a potential of 200 volts. Then we know what is the charge on this, right? Charge is equal to 200 into C. So that's going to be the charge on this. What is the capacitance given by? epsilon naught A by D, where D is 4 millimeter. Okay. Now what we are going to do is a dielectric slab of thickness 4 millimeter is inserted between the plates. Now, when you're inserting the dielectric slab between the plates, its capacitance will increase K times, correct? So the new capacitance will become K into epsilon naught A by D, correct? And the charge is going to remain constant because you have disconnected the battery, right? So charge will remain constant, but capacitance has increased. So what will happen to the voltage? It will decrease, correct? This is what will happen because the product has to be constant. Q is constant. Why is Q constant? Because of law of conservation of charge. And when Q will not be constant, suppose if you connect it, if you still have the battery connected, then V will be constant, not C. Okay. V will be constant, not Q. Okay. Are you clear about this?
Yes, sir.
Yes, sir.
Yes. Rahil, can you explain? When I insert a dielectric, what happens? Or if not Rahil, then can somebody else explain? Yes, Alvin, go ahead.
So if you insert a dielectric in that, the capacitance would increase and the voltage would decrease.
Okay, okay. 1 minute. Let's go
Potential.
one by one, step by step, Alvin. So when I insert a dielectric, it will definitely increase the capacitance, correct? No doubt about it. Yeah, just be with me. Just you can answer.
Yeah, sir.
Yes, no doubt about it. Now, there are two cases here. Case one is when battery is still connected, what will happen? When battery is not connected. So these two, can you tell me, Alvin? Last class we saw when battery is still connected, what will happen? Now we are seeing when battery is already removed. Both cases I want you to tell me.
The charge remains the same
When?
when the battery is disconnected.
Yes, when the battery, very good,
capacity.
very good. Others, Rahil, please note it down. I think you missed this part of it last class.
Yes, sir.
Yeah, I could see, you were not logged in at that time, right? Okay, just carefully observe this. Others also, right? Important point which Alvin is sharing, which is important, critical for competitive exams. Yeah, go ahead, Alvin.
In a charge capacitance, when we remove the battery, the charge remains the same.
Yes, according to law of conservation of charges.
Yeah, sir.
Very good, very good. When charge remains same, then you go to this equation, Q is equal to CV. So when capacitance has increased, charge has to be constant, then what will happen to V?
It will decrease.
Very good, very good. Excellent, Alvin. Now, tell me the other case, when battery is still in contact. Suppose battery is still connected, then what happens?
The charge is constant.
No, Alvin. No.
The voltage will be constant.
Yes, Akila, very good, very good. Because you are connecting to the battery, the sole purpose of the battery is to maintain the potential difference.
Yes, sir.
So V will remain constant. So in this equation, if V is remaining constant, but capacitance is increasing, then what will happen to charge? I'll write it separately.
It will increase.
Yeah, go ahead. Yeah, tell me. It will
Increase.
Yes. So Q is equal to capacitance into V. Capacitance is going to increase because I've inserted the dielectric. Voltage is going to remain constant, which means when capacitance increases, charge also will increase. Who is increasing the charge now? Who is responsible for increasing the charge? Who will provide that extra charge?
The capacitance.
Capacitor cannot provide. Okay. Battery will provide. Battery is still connected, right? In that case.
Yes, sir.
So battery will provide that excess charge. Only battery can provide that excess charge. Clear? When battery is still connected. All right.
Yes, sir.
So that's a distinction. Now, Rahil, can you tell me the two cases?
Yes, sir. So
Yeah, go
when
ahead.
a battery is connected, sir, the voltage will be constant. So
Yes.
the capacitance increases due to dielectric
Very
constant.
good.
The charge will also increase, but when the battery is disconnected, the charge will remain the same and the voltage will decrease.
when capacitance increases because of inserting dielectric, correct?
Yeah.
Very
Yes.
good. Very good. Excellent. Okay. I want everybody to get that point. Okay. Next is this, right? Next point is that now, because we understand that the voltage decreases, I want to increase the voltage. Okay. But still keeping the charge same. Then I have to again decrease the capacitance. Correct. That's the only way. Correct.
Yes, sir.
Yeah. So I have to increase the voltage to original value, which means I have to decrease the capacitance to the original value, but still having the dielectric inside. So that's only possible if I can still extend the plates further. Clear?
Yes, sir.
So we are moving the plates apart. Because when I'm going to move the plates further apart, the potential will decrease. And consequently, the capacitance will decrease. Consequently, the voltage will increase. Therefore, charge will still remain constant only. Okay, so you're going to increase the plates by how much millimeter? 3.2 millimeter. Clear?
Yes, sir.
Yes.
Yes,
okay.
sir.
Now, what has happened now? Charge is anyway same as what it was before. What else is same?
Voltage.
Voltage is also same. Only to maintain the voltage, you are doing this, shifting of the plates of the capacitor by another, extending it by another 3.2 millimeter. So second thing is voltage remains constant. If charge and voltage remain constant, what about the capacitance? If charge is same,
Sir.
voltage is same, then what about the capacitance?
It will be the same.
That also has to be the same, correct? So the capacitance of this new setup will be same as the capacitance of the original setup. What was the capacitance of the original setup? Simply epsilon naught A by D, correct?
Yes, sir.
And epsilon naught A by, what was that D? D was 4 millimeter, correct?
Yes, sir.
Yes. Now, what is the new expression for capacitance when you have the dielectric and you also have a gap in between? Then the formula to be used is what? This one, correct? Epsilon naught A divided by D minus T plus T by K, correct?
Yes, sir.
So the D minus T is nothing but the air region and this T by K is nothing but the dielectric region. So if you see, what is the air region? How much is the air region length?
3.2.
3.2. So I'm writing 3.2 millimeter plus the dielectric length. The dielectric, how much distance it is occupying? 4 millimeter. I'm just substituting this in the formula, correct? D minus T, I'm directly substituting as 3.2, correct? Because what is D dash minus T? 7.2 minus 4. That becomes 3.2. So I'm directly writing 3.2. Is it okay for you?
Yes, sir.
Yes.
Yes, sir.
So epsilon naught A, I'm cancelling on both sides. Then it is just simplification. So 3.2 plus 4 by K is equal to 4. This 3 point I'm taking to the other side. So it becomes 0.8. 4 by 0.8 is equal to 4 divided by 0.8 is equal to K. So K is nothing but 40 by 8 or 5. Is this understood?
Yes,
Yes,
sir.
sir.
Okay. Now you can take it out. Yeah, I'll just give you a few minutes to take it down. I think the exams are postponed, Rahil.
Sir, they're telling, sir, I don't know, sir, that since they did not complete any portions, they were like, we have to postpone it. It's not confirmed yet, but it's probably postponed.
Okay, because from the board, we got the information that it's happening on 3rd week of October.
Okay, sir.
From the PU board. But anyways, I with father, I have not checked. I will be coming on Monday. Tomorrow, I will check with him.
Okay, sir.
Okay, please go ahead and just go through take it down. And once you're done with this page, then I'll make a move to the next one. Any doubts are there? Just let me know. During the learning process, do not worry about the time that you're taking. But once you learn, then you must master it by a lot of practice. I'll give you some practice questions today.
Done, sir.
Done, huh? Okay, I'll move this. Okay,
So 1 second.
Sure, sure. Once you're done, you tell me, Makila, then we'll move.
Yes, sir. Yes, sir.
Completed, ma? Okay. Shall we move?
Sir.
Okay. Once you have completed, tell me.
Yes, sir.
Done, ma? Shall we go to the next question?
Yes, sir.
Okay.
Yes, sir.